All right, folks, this is a talk on the evolutionary saga of Python packaging. I'm Nafiul. I'm a developer advocate at Sonar. We build something called Sonar Lint and Sonar Cloud and Sonar Cube, and it's effectively a static code analysis tool. So your security vulnerabilities, your code smells, things like that, we analyze it so that we make sure that it doesn't get into your final production code. And this is kind of what Sonar Cloud looks like. It tells you, hey, in this part of your code, as you push it up, there's something wrong. This particular example is with Django, but we do it for a whole host of other things, including machine learning libraries. Anyways, so this perspective, this talk is really from the perspective of a user, right? This is a person who uses Python packaging. It's not that I don't care about the people who go through all the pain of actually packaging Python packages. It's just that for the purposes of this talk, I just don't care. So how do we get here? Most of my talks, I have to be honest, are really about procrastination. It's because I was supposed to be working on something, and then I got stuck, and then I just went into investigating it, and then I have a talk, and that's effectively why I'm here. So I needed to install a Python package on Windows, as one does. And unfortunately, the package just wasn't installed, and frankly, no matter what I did, it wasn't installing. And when it didn't install, it actually told me pretty clearly that, hey, Microsoft Visual C++ 14.0 hasn't been installed, so you might want to install that. I was like, okay. So then I tried to do that, and then I got this unspecified error of unknown origin, as one does when installing stuff on Windows. And this reminded me of the good old days. Anybody remember this? Can anybody tell me what this is? Right? Okay, so this is back in the old days, what you would do is you would download an exe file for your favorite Python packages and run an exe installer on Windows. And highlighted over here is a little package called SymPy, which does what you call symbolic algebra for you. And this is basically what I use to cheat on all my math exams. So thank goodness for Christoph Golke and the University of California. But anyways, this is a long time ago. So I thought to myself, hey, at this point in time, Microsoft has given up on Windows, right? So that's why they have Windows Subsystem for Linux. So why not use Windows Subsystem for Linux, right? This could work. And then you don't have enough permissions to run the package. So question is, my friends, why does it have to be this hard? Why did I have to use that meme? And so to answer this question, we must ask a very philosophical question, I think. What is a package? I mean, at this point in time, you clearly understand I'm going through an existential crisis here. And so a package is really someone else's code that you can use. You probably don't pay for it, but you're using it. And the important part is being able to use it, okay? And that means your package needs to be compatible with your version of Python and the operating system that you're using it with, right? That's how you can use it. Otherwise, you can't use it, okay? But you are telling me you're going to be like, but Nafiul, Python runs on everything, right? All of it, ARM, Intel, back in the good old days, PowerPC, right? Right?
You would be so wrong.
Well, buckle up, my friends, because this is going to be a bumpy ride. So we start first with the very first way that we managed packages, and that was by copying and pasting. You would effectively copy some code from somebody else, you'd paste it in your computer, and hopefully it would work. And so in a way, you are the package manager. But at some point, people over at Python land were like, maybe this is not a good idea. Maybe we kind of sort of need to have a standardized way of doing things. And voila, the vaults of Parnassus was born. Now, the vaults of Parnassus were named after the vaults in Mount Parnassus. And apparently Mount Parnassus is where the god Apollo used to live. And in his vaults were amazing treasures of art and sophistry and whatever other things Greek gods put in their vaults. But that was the idea. That was what the Pythonistas of old. I mean, they're not that old; they're still here. So, we're thinking about when they made this, and this is what the vaults of Parnassus look like. you can see, and so it was effectively a website with links to other websites, okay? And you needed that because the Vaults of Parnassus started in 1996, and guess what? Google didn't exist until the end of 1996. So you had websites that had links to other websites. And you can see that this is a very old image because this is a link to SourceForge. And nobody puts stuff on SourceForge anymore. At least I hope you don't. But yes, if you know what SourceForge is, congratulations, you're old. Hey, that guy over there, he knows what I'm But it also included other important information, like what platform it would work on, like Linux. So from the very onset of Python's packaging woes, people had to specify, hey, this is going to work on Linux, this is going to work on Windows, and back then there were many kinds of Windows. So for example, there's this thing called IDE Studio. It was actually an IDE, an integrated development environment written in Python for Pythonistas. It was created a long time ago, and so it would work on Win32. And you needed to specify Win32 at the time because Windows 95 was the latest version of Windows, and it was the first 32-bit of Windows. Before that, you had 16-bit of Windows, right? And so you had Linux, you had Solaris. But sometimes the people who made the packages weren't exactly that specific. They were like, maybe it will work, maybe it won't work. And that's why you have the possibly Linux tag, because it could possibly, conceivably, maybe, hopefully work. And this was all the way back, and this is back in 2007. So even in 2007, not all the way in 1996, but in 2007, the Vaults of Parnassus just had 340 to 500,000 views. Hits per month. And now we do 300 million per day on PyPI. So that gives you, that's effectively in a nutshell what happened to the Python community. It kind of had hockey stick growth. So, there were some pros, there was a centralized place to share all your Python packages. It's better than emailing or shooting tar balls at people, right? Freedom, or maybe too much freedom for repository owners to define how their packages were installed. But it's not really automated. Means of packaging is not standardized. So in a way, you're still the packaging. The first thing that really changed, I would say, in the Python world towards making packaging a more standardized experience was distutils. And this came around, I think, in 2000. Correct me if I'm wrong, anybody. Maybe it started early, but came around 2000. And this was really the first attempt at standardizing Python packaging, and it came around Python 2.0. And what it effectively had was basically, hey, these are your fields. They have to be there when you make a package, right? And most of the metadata was included in something called package info. And you'd still see this in most packages these days. But here's the thing, a package, at least a Python package, is more than source code. It can also include binaries, right? And so at this point in time, I gotta say, I have to come clean about Python's original sin, okay? So Python is the most successful glue language in the world. What does that mean? It means when we see something we like in another language that's compiled, that has a C foreign function interface, we sort of just take it. We add Python bindings to it and say it's Python now, right? So, English language. Yes? Yes, very much like the English language. Like the word guru is actually not an English word. It's an Indian word. But anyways, I digress. So we went around, taking other people's good stuff, and you might think there is a problem with that. And there is a problem with that. But that had consequences, right? And so to demonstrate this, I have a very complex flowchart, and it's kind of, I think most of it is still, you can still see it. But basically, you got your source code, right? And your source code can be of two types: Python code, C, Rust, Cython, Fortran, Carbon. I was talking to one guy yesterday. He said, I managed to slip in Zig into my Python package, and I just looked at it for a very long time. I didn't say anything. I didn't want to be rude. I'm in English, But you see, you have to build a static object. You have to compile this object and make it available to Python, right? And this is what a person looks like trying to do it. Okay, this is an accurate description, and so that it can be used by the Python interpreter. And the thing is, we've been doing this for a very, very long time. How many of you know about NumPy? Can I see a raise of hands? Great, everybody knows about NumPy. So NumPy's predecessor, numeric. How many know about numeric? This is nobody, maybe one person. Okay. So numeric is the predecessor to NumPy, and it was built on Fortran's BLAS and LePack libraries, right? So we've been doing this for a very long time, and I would say NumPy is very, very popular, very, very successful as a package. But we've been continuing it to this day. Robin, which is a web framework, uses Tokyo under the hood, which is an asynchronous runtime from Rust. How many of you have heard of Polars? Right, lots of Rust in there. We saw something we liked and then we took it. So you don't just have Python's packaging problems, right? You have every language's packaging and build problems. So Python's unique abilities are kind of like a double-edged sword. So anyways, back to disutils. So disutils also introduced something that allowed you to have two types of distributions. One was sdist, or source distributions, and the other was bdist, your binary distributions, right? Problem with that is there are lots of kinds of binary distributions. There's not like one binary distribution. But anyways, so binary distributions work great for NIC systems, but Windows and Mac kind of got left out. Mac not so much, because eventually Mac would get Mac ports, and Mac is also very close to the Unix system, so GCC and other stuff works really well, but Windows kind of got left out. And the thing is, disutils was not made for the kind of popularity that Python received. I've spoken to a lot of folks who were with Python from the very beginning. Most of them tell me, we never thought Python would be this successful, right? So when disutils was made, stuff like dependency management, why would you need that? One package is all you need, right? Versioning, why? Why would you need that? Standardized distribution formats? We will think about it later, right? If we get bigger and more successful. So in a way, you're stealing the package manager. Around, I think I would like to see 2004, we had the Python packaging index. And the Python packaging index is basically, at this point in time, it's just a facelift over the Vaults of Parnassus. You still have your SourceForge links, but maybe GitHub is creeping in a little bit. And it wasn't until 2014 that you have the modern system that we have today, where you upload everything to PyPI, and that's hosted by Fastly on a CDN, and you can easily download it and all that good stuff. But this is what was going on in 2004. I would say the next big thing that happened in the Python world was setup tools. Now, setup tools had the kind of impact that WSGI had on web development in Python. How many of you have heard of WSGI? Yes, yeah, right. So when Python web development was starting up, there were many servers at the time, many people did things in different ways, but WSGI, the Web Standard Gateway Interface, really made Python web frameworks more accessible to everybody else. And setup tools made packaging more accessible to Pythonistas in general. And I know a lot of people have a lot of pain associated with setup tools. I get that. But the truth is that it had its impact. It did its job. And the way that it worked is, so this is what disutils look like. It's pretty simple. You got your name, your version, your packages, your author email, et cetera, et cetera. Very simple, not too different. But this is what setup tools look like. And if you take a look, it has something called install requires, it has further clarifiers, it has entry points. So install requires, basically, it allowed you to add dependencies to your packages that could be installed, right? This is the first time that it's happening. And it also had something called the find packages function that allowed you to find the packages that were inside, that were already installed. So you had some rudimentary package management to go along with it. And of course, it also had entry points. So when you type in pip or conda or whatever, those things are entry points. The way you basically command them on a command line, that's basically it. And this is the first thing that introduced that. It also had much richer metadata. So setup tools really changed the way on multiple levels in really making Python a more elaborate packaging ecosystem. But it also introduced something that was really, really interesting for the time, and that was the egg format. And eggs were essentially a zip file that contained the contents of the Python package and the method, right? But you might be like, hey, we already had zip files, so what's so special about this? Like, why care about eggs? And the thing is, this was really the first format that was able to combine both binary and source distributions together. And so you could have eggs that had both. And this is kind of what it looked like back in the day when you were fusing SDIST and BDIST. But anyways, they also introduced new binary distribution formats like BDIST WinInstall, which was for Windows, and RPM, which stands for the Red Hat Package Manager, but basically it's for Linux. And this was the first automated tool that allows you to install Python packages from the pipe, right? And so you had, did I gloss over easy install? So anyways, basically, we also had easy install instead of tools. I completely forgot about that. But easy install was the first, I would say, Python package installer. Anybody still remember easy install? Yes, Miguel, you do? Okay. But basically, it wasn't very easy to install packages with easy install. But it's a start. So set of tools really added a lot of things, from providing a better way to package things, added better binary distribution, added easy install. I say added better dependency management, but really there was no dependency management until this point. So it added dependency management and added more clarifiers to package search and added entry points. But here's the problem. You still couldn't uninstall packages. You kind of need to do that, don't you? Right? And there were also issues with dependency management. So how many of you have scraped a website? Right? How many of you have used LXML? Right. Everybody who said I scraped a website should have also raised their hands when I asked, have you used LXML? Because guess what? You were using LXML this whole time. And easy install had a really difficult time installing LXML, which was kind of like the meme at the time. But easy install couldn't also verify the integrity and authenticity of packages. Now you might be like, well, this point in time we're just installing packages. And you're right. But as you get bigger, as the community gets bigger, as more and more people start to use Python, some bad people come along and they want to hack your packages. They want to inject some malicious code into your packages, and they want to do all kinds of nefarious things, as bad evil hackers tend to do. Right. So in a way, you're stealing the package. The next thing I would say that happened that was pretty big in the Python world was virtual env. And the thing is, Python installation started to get cluttered with old and new packages. And the way that we eventually came to a solution on how to manage all of this was to basically have a virtual environment, a little environment that had all of the packages that we needed for a particular project. And we still use this to this day. And if you think about it, virtual env at that time was an absolute godsend, because it was released in 2008, and so was Python 3.0. And we all know how difficult the transition from Python 2 to Python 3 was. Now, please. Okay. Okay, now my clicker doesn't work. Okay. And eventually, virtual env became standardized in 2011 under PEP 405. And eventually, we got pip. Now, pip was the successor to easy install. And it's something that we still use today, even though there are more tools out there, but under the hood, they still use pip. And there were many changes that pip made, but easy install tried to install packages one by one. Pip installed your entire dependency tree and installed things in one go. So it kind of did a reduce on it. Pip also had the ability, magically to uninstall packages that easy install did not. And for the first time, we also had requirements.txt, which I think we still use today most of the time, but it's changing. Pip also enforced secure connections, reducing man and middle attacks. So as you see, Python is slowly starting to care about how do we package this, to how do we package more of this, to how do we package this securely. And this also shows how Python is growing up as a language. The thing is, even with all of this, binary distributions still needed to be improved, right? And so the next big thing that we came up with was something called wheels. And the reason we called it wheels is because so that we wouldn't reinvent the wheel again. Get it? Huh? And wheels are actually pretty elaborate in the sense that they have the compiler version, the operating system, the architecture as well, because now before you had PowerPC Mac, Intel Mac, and now you have ARM Mac, right? And now you have ARM Windows, you have Intel Windows, so it also needs to work for your particular architecture. So even binary support, even better support for binary distributions. So, I tried to install PESQ, which is a dependency for many libraries out there. I'm thinking that if I used the wheel version, it would totally work. But unfortunately, what happened is I got this error saying that I needed to install Visual C++ 14.0. And then I got the unspecified error of unknown origin. So it's still not completely solved as a problem. It's better, but it's still not completely solved. So in comes Conda, coming in like a shining knight. How many of you use Conda? I know you're all data scientists because you use Conda. Anyways, so Conda, let me just explain a little bit about how package management works before I explain Conda. So, in your operating systems, you got Windows, you got Ubuntu, you got Mac. In your package managers, you got Winget, you got Chocolatey, you got Pacman. If you've never heard of Winget or Chocolatey before, that's because they're Windows package managers. And you haven't heard of them because nobody really uses them because they're bad. And on top of that, of course, you have your applications. And of course, on top of that, you have your application package manager. There was no icon for pip, so I just screenshotted this. Hey, what am I supposed to do? They don't have one. So Conda was like, all right, enough with this application package manager stuff. We are going to be a real package manager. It took a page out of Pinocchio's book and wanted to be a real boy. And so Conda isn't just a Python package manager. It's a package manager like Brew, like apt, like Yum. Have you heard of those package managers? Yes, that's because they're good ones. And Conda packages contain precompiled binaries for every supported platform. Now, I just want you to imagine the poor person that has to precompile all those binaries for all the weird operating systems you people use. It's not my fault, it's your fault. Anyways, so you never need to compile anything. And this is why scientists really like this. It's they don't care about the code, they just want to run the code, right? Am I right? Right. So Conda isn't limited to Python packages, but you can also install R packages and entire applications. Conda also had the ability to create isolated environments because they were like, hey, virtual env is a good idea. Let's do more of those. But you see, everything has pros and cons, right? So how many of you have used Polars? A lot of you. Polars uses a package called Maturin. And the version of Maturin available on Conda is 1.3.1. And I checked it. And the version that's available on PyPI is 1.6.0. Thing is, it takes a while for all the stuff that's changing open source to get upstream to Conda because somebody actually has to manually compile it, check it, see if it works. If it doesn't work, they'll probably get a lot of hate mail. I don't know. This is bad business, yo. Anyways, so if you're using Windows, I have to say, Conda is still the best tool to install Python packages on Windows. It's just that it comes with a lot of stuff. It is a very big installer, and often you won't get the latest and greatest. So I think around 2011, we got something called pipenv. How many of you have heard of pipenv? Most of you. How many of you have used pipenv? Most of you. All right. So this was basically something that was created by the creator of requests, Kenneth Wrights. And the idea was, since virtual envs are such a good idea, why not combine the two? Could be a good idea, right? Could work. And so that's what they did. They also introduced something called a pip file. And a pip file was kind of like the precursor to a PyProject.toml that was more, I don't know, directed about how packages were, what were dev packages, what were packages themselves, where these packages would come from, et cetera, et cetera. And it also had something called a pipfile.lock, so you could get reproducible environments. So you could get the exact version that you wanted installed. And it also allowed you to check all your transitive dependencies. So transitive dependencies are dependencies of your dependencies, right? So if you have pipenv, it has transitive dependencies, and then they have transitive dependencies, et cetera, et cetera. It also was able to check your install lists for security vulnerabilities. So if you are about to install, say, a compromised package version for Django or NumPy or whatever, it would warn you. So slowly you're seeing the Python community take security more seriously. And then we get to poetry. But first, PEP 518 and 566 were really the ones that introduced PyProject.toml. We wanted to standardize the way Python packages were distributed even further. And so it was kind of like the successor to setup.py that was set up all the way back in setup tools. So anyways, back to poetry. So poetry basically uses the PyProject.toml file over the pip file. So it's more standardized, but I do have to tell you, poetry doesn't adhere 100% to the PyProject.toml spec. There's another one that does at the top. And it also allowed you to very easily publish your packages as well. Now, during this time, there were many ways in which people were thinking about how do we install Python packaging. One of the places that we took inspiration from was from Node modules. So they had their own way of Python packaging, and that effectively was PEP 582. It was trying to introduce Node module like a Node module like system for Python. It was, I think, __ dunder, Py packages dunder, something to that effect. But the thing is, PEP 582 was rejected. So right now, PDM is really more compliant. If you want to use PDM as a package manager, you use it because it's more compliant. It adheres more strictly to PyProject.toml spec. And in 2023, we got something called UV. How many of you have heard of UV? Right. So UV is a new package manager that is actually not new. It basically just re-implements pip in Rust. And it's better because Rust. And it quite literally reinvents the wheel. I mean, they're like, hey, this thing works, let's just make it faster. And it aims to be the cargo of Python. So if you've never used Rust, this might not be something clear to you, but basically Rust has a package manager called cargo, and their packages are not called packages, they're called crates. So basically, apparently it's the gold standard of all packaging in the world. Everybody loves it. And so it's trying to become the cargo of Python. So one tool to not only install packages, but build and run your applications. And it's very fast because Rust. And it has a lot of bugs on it. People are using it like crazy. And they're closing a lot of issues as well. So you can see 354 open for 1,355 closed. So it's working at a very frantic pace. It's really still too early to pass judgment on UV, but that just goes to show that people are still really working pretty hard on Python packaging these days. So at the end of the day, it's really the binaries. It's the binaries that are effectively holding us back. And Python packaging has really improved by leaps and bounds over the past decades. If you're complaining about Python packaging now, imagine how bad it was in the 2000s. For Python, dependency resolution is still a problem. And let me explain it to you this way. So if you have package A and package B, and they both need different versions of package C, you are going to have a problem. And that's what I think PEP 582 was trying to solve, but it wasn't able to. So in a way, Russ is looking at us like, if you got packaging problems, I feel sorry for you, son. We can't have cargo because we have too many language dependencies. We basically take anything that's good and compile, anything that has a C foreign function interface, we will use to our advantage. Python packaging will always have problems associated with binaries, but packaging continues to improve and expand all the time. Name and point, PyIodide is basically a project that allows you to run Python on WebAssembly. So in Python land, we ask not what problems we can fix, but rather what new problems we can acquire. And and by the way, you might think like, what does this guy know, right? So they had a WebAssembly summit, and a big part of it was about Python packaging. And one of the key quotes that came out of the summit was, the only conclusion that we can reach when it comes to Python packaging is that there is no conclusion. And this is called the Lemberg paradox, because this was coined by Marc-Andre Lemberg, who's a CPython developer. So from time to time, you will still have an unspecified error of unknown origin. So in a way, you're stealing the package manager. Thank you. So if you could scan this QR code and answer some of the questions that my product manager has told me to ask you guys, I would appreciate it. In the meantime, feel free to ask me questions.
Did you install the package again?
Yes, I did.
What did you use?
So basically, the way that I managed to solve it is that there were permission errors on Windows Subsystem for Linux. Apparently, you need to install it in a particular way. And so I was able to get it to install in Windows Subsystem for Linux. And I wasn't really able to install it on Windows proper because I wasn't willing to install Conda, because Conda takes forever to install. Yes.
I use pip, and I want my colleagues to respect.
Yes. So basically, you are the maverick of your company, and I mean probably. If it makes you feel good about yourself, why not? But so you use pip, and what do your colleagues use?
Probably pip as well.
Okay, so what's the problem here?
I keep guiding them to something more up to date.
I mean, if it works.
The truth is, like download whatever ML project I'm copying from GitHub and install with whatever they say to install with.
Yeah, that's a good strategy. All right, next one. Any more questions? Yes.
Python is obviously very popular with the LLM community. But they are primarily pushing it. Why do you think that is? And do you think Python will continue to be the core key language for LLM related? I know they're kind of expanding that to others, but would you see something across, I don't know, much further? So interesting.
I think one of the superpowers of the Python community is that we're very open to all kinds of people. Like if you take a look at NumPy, it was actually made by a guy called Travis Oliphant, who was a PhD student in medical technology or medical research or something like that. The thing is, just like the language itself, it goes around taking all the good stuff from other languages. I know it sounds really bad, but it's great for us. The Python community is also very welcoming to people from all kinds of different disciplines. So that's why you have packages on geospatial stuff. You have packages created by geologists and stuff that does temporal things. I don't know. Like basically, we're very open to people coming in. So I think that's one of the reasons why the LLM community, but also because we have NumPy, we have Pandas, we have all this stuff that is used to make the tensors, that is used to create all these neural nets, that is used to create your LLMs or whatever. And like PyTorch, TensorFlow, all of this stuff that comes from the Python community. So it only makes sense that the eventual evolution towards LLMs would also come from the Python community. Yes, good sir.
So I'm relatively new to Python world. I'm more of a Java and JavaScript guy.
Don't worry, don't. You're welcome.
So you're safe here.
You're safe here. Nobody's gonna hurt you. Like I said, Python community takes out everybody's good people. Oh wait, did I just say that?
So like, will this help resolve the problem of Anaconda, these libraries where you have to create a virtual environment for, so you don't mess up the different dependencies? Or you still have to do that like virtual environment thing?
I think virtual environment, so PEP 582 was thought about for a while. And the thing is, the reason virtual environments were still selected to be used is because it just really worked for most, even the edge cases. And the thing is, this has been used for a very long time. We're talking about all the way back in what, 2004, 2010. So if it works, don't fix it, really. That's kind of like thing. So you'll probably still need to use virtual environments way into the future.
I mean, it just seems very confusing and complicated.
It is. Python packaging is not fun. And it's not fun, not only for newcomers, but also for people who've been doing this for a long time. Yes.
What recommendations do you have for packaging binary distributions for code that's developed in Python? Because the default is not, it's a compiled language. I know there are certain things out there, Cypher, etc. But like, what would be the approach that you would take for that?
Personally, I think now if you're doing something from scratch, use Rust because it has a very nice toolchain and works very well and has a good build system. There's a reason why it's taking over so quickly. Shorter answer to a longer answer is that Rust hits the sweet spot of being abstract enough and low level enough where it's easy enough to work with, has good tooling around it, and I do mean very good tooling. Also has good build tools around it, so it allows you to work with Python very easily. All right, with that, I'm done. Thank you very much.